the universe never ceases to surprise us. Just when we think we understand the basic rules of planetary formation, along comes a discovery that turns everything on its head. The James Webb Space Telescope has recently unveiled something so improbable, so unexpected, that it might just force us to rewrite the textbooks on how planets are formed. The discovery: binary planets, more specifically, jumbos, or Jupiter-mass binary objects, found within the Orion Nebula. These celestial oddities seem to challenge everything we know about how planets form and evolve. You might be wondering, what exactly are these jumbos? Well, as the name suggests, they are massive, Jupiter-sized planets that orbit one another, but here's the twist: they don't have a central star. Typically, we expect large planets like Jupiter to be part of a solar system, revolving around a central star just like Earth and the rest of our solar system planets. But jumbos are different. They're free-floating, yet somehow bound to one another. Imagine two gigantic planets dancing through space, locked in a gravitational embrace, without the need for a sun to keep them in line. And the James Webb Space Telescope has found over 40 such pairs in the Orion Nebula alone, a discovery that has shocked astronomers and planetary scientists worldwide. But how did JWST, which is orbiting nearly 1 million miles away from Earth, manage to spot these elusive cosmic duos? This is where things get really interesting. The James Webb Space Telescope uses a technique called gravitational microlensing to detect objects that are otherwise too faint or too distant to be seen. Gravitational microlensing takes advantage of a phenomenon predicted by Einstein's theory of general relativity, where the gravity of a massive object bends and magnifies the light of a background star. It's like using a cosmic magnifying glass to spot things that would typically be invisible. While Einstein himself was skeptical about the practicality of this method, it has proven to be incredibly useful in observing distant phenomena in space. In the case of jumbos, the gravitational lensing effect allowed JWST to capture faint glimmers of these binary planets, revealing their existence for the very first time. But that's not all. The way these jumbos orbit each other is just as bizarre as their existence itself. Typically, binary systems consist of stars or, occasionally, larger celestial bodies like black holes. But in this case, we have two massive planets orbiting each other at a distance of 200 astronomical units. That's 5 times the distance from the Sun to Pluto. For planets of this size, such a wide orbit is extremely rare. So how did these planets form? And how did they end up orbiting each other at such an enormous distance? According to current models of planetary formation, this shouldn't be possible. Planets are supposed to form within a protoplanetary disk around a young star, slowly accumulating matter over millions of years. But the existence of jumbos, orbiting each other without a central star, suggests there's much more to planetary dynamics than we currently understand. Let's dig a bit deeper into the science. One of the most fundamental concepts in planetary formation is the opacity limit, a theoretical barrier that restricts how massive an object can become without a nearby star. This limit essentially defines the maximum size that a planet can reach when forming in interstellar space. The basic idea is that without the intense heat and radiation from a star, it's extremely difficult for gas and dust to condense into a solid, planet-sized mass. This limit has guided our understanding of how planets form for decades, and it's a central part of why jumbos are so perplexing. According to the opacity limit, planets like jumbos simply shouldn't be able to form in interstellar space, let alone exist in pairs. Yet, the discovery of jumbos in the Orion Nebula seems to defy this theoretical boundary, suggesting that our models of planetary formation may be missing some crucial elements. So, what could explain the formation of jumbos despite the opacity limit? One intriguing theory involves magnetic forces. Magnetism might play a crucial role in how these binary systems form and interact, potentially acting like cosmic glue that keeps these massive objects together, even in the vast emptiness of interstellar space. The presence of magnetic fields could influence the dynamics of planetary formation in ways we have not yet fully explored. If magnetism is indeed a factor, it could explain how jumbos maintain their unusual orbits and why they seem to exist more frequently than initially expected. Magnetic interactions might help stabilize these binary systems, allowing them to persist over millions of years. This concept could revolutionize our understanding of planetary formation, suggesting that magnetic forces might be more important than we ever imagined in shaping the architecture of planetary systems. The implications of this discovery are profound. If jumbos account for nearly 9% of observed wandering planets, it challenges a long-standing belief that smaller celestial bodies rarely form binary systems. Traditionally, binary systems have been associated with stars or massive black holes, but the discovery of jumbos suggests that binary formations could be far more common, even among planet-sized objects. This revelation forces us to rethink our theories about how planets interact and evolve over time. Are binary planets more common than we thought? Could there be similar pairs hiding in other regions of space, waiting to be discovered? These questions now sit at the forefront of planetary science, as researchers grapple with the implications of jumbos on our understanding of the universe. As we continue to explore the cosmos with the James Webb Space Telescope, it's likely that more secrets like jumbos will come to light. This discovery is just the beginning, offering a glimpse into the complexity of planetary formation that we're only starting to understand. JWST's unmatched capabilities are allowing us to observe distant phenomena that were once beyond the reach of even our most advanced telescopes. It's opening up new avenues for research, and it's clear that our journey through the cosmos is only just beginning. The discovery of jumbos has set the stage for a new era in planetary science, one where we might need to reimagine how planets form, evolve, and interact. So, what do you think about jumbos? Could there be more binary planets out there, hiding in the depths of space, waiting to be found? This groundbreaking discovery has certainly given us more questions than answers, but that's the beauty of science, it keeps pushing us to explore the unknown. Let us know your thoughts in the comments below. And if you enjoyed this video, don't forget to like, share, and subscribe for more updates on the latest cosmic discoveries. With the James Webb Space Telescope leading the way, who knows what other surprises await us in the vast expanse of space. What makes this discovery even more captivating is that it hints at a much larger, hidden population of similar objects in space. Jumbos may be just the tip of the iceberg. If binary planets can form and exist in such conditions, it raises the possibility that space is filled with more rogue planets and even other unconventional celestial bodies that we've never seen before. These objects could be drifting through interstellar space, free from the gravitational pull of a central star. Some scientists even speculate that there could be entire clusters of these binary planets out there, moving like cosmic nomads across the galaxy. This tantalizing thought only deepens the mystery. What else could be lurking in the vastness of the cosmos that challenges our current understanding of planetary science? The discovery of jumbos also reignites discussions about the potential for life beyond Earth. While binary planets like jumbos themselves are unlikely to host life as we know it, their presence could indirectly influence the conditions of nearby space environments. If these massive bodies can form without a star, could they have enough gravitational influence to shape the formation of smaller, potentially habitable planets in their vicinity? This brings us closer to understanding the diversity of celestial formations and the potential pathways for life to emerge elsewhere in the universe. It's a fascinating consideration that adds another layer to the search for extraterrestrial life, highlighting how JWST's discoveries are not just about planets but about broader cosmic processes that could make life possible in unexpected places. With every new discovery, the James Webb Space Telescope continues to redefine the boundaries of what we know about the universe. From unveiling the deepest cosmic structures to observing distant stars and galaxies, JWST has already proven itself as one of the most revolutionary tools in modern astronomy. And now, with the detection of jumbos, we're faced with yet another cosmic enigma that may take years of research to fully understand. As researchers dive deeper into analyzing these findings, we can expect new theories and perhaps even new models of planetary formation to emerge. It's a thrilling time for astronomy enthusiasts, as each discovery by JWST not only broadens our knowledge of space but also fuels our curiosity to explore further. What else might we uncover as we continue to peer into the depths of the universe? The possibilities seem limitless.